So next talk is on. So now that you have the background of why Micronaut and what Micronaut is, a lot of I left out of that talk was anything related to data access or anything like that, which I've been saving for this talk, which is on Micronaut Data. For those of you, I don't know if anybody actually missed my previous talk, but if they did, my name is Graeme Rocher. I'm the creator of Grails and Micronaut, and I'm an engineer at object computing and a Java champion and various other things. For this talk on the agenda today, we have I'll do an introduction to Micronaut Data. I'll do a technical overview of how it works. As with my other talk, I enjoy and heavily focus on live coding and demos because it's a lot of fun, even though things can go horribly wrong, but hopefully they won't. And at the end, we will do some Q&A and I'll take questions and hopefully we'll all have a good time. So first of all, for those who are unfamiliar with the history of data access toolkits in the Java space, I think prior to Ruby on Rails' active record revolution, there was a lot more work doing database access, writing database access code in Java. Ruby on Rails really did show the way in terms of how to obtain good productivity when writing database access code. And Gorm, which Grails was obviously heavily inspired by Ruby on Rails. Gorm was the really first framework or toolkit to bring the active record pattern to the JVM. And that's why, for a lot of reasons, Grails is 13 years old now and it's been around for a long time. But in 2007, it was a revolution in terms of the JVM and productivity. And a lot of that was down to Gorm, which was essentially built on top of Hibernate and implemented all your database access logic for you. So you just defined a person class and then you could do find by name and it was all automatic. After those technologies came various other technologies that essentially replicated the approach, like Spring Data and Delta Spike and so forth. And all of them are based on runtime analysis. So like I said, existing solutions like Spring Data and Gorm, they rely heavily on reflection, which, if you had seen in my previous talk, we agreed was not necessarily a good thing, and also heavily on the creation of runtime proxies, either with bytecode generation or JDK proxies or whatever it may be. In the case of Gorm, actually, we used a lot of AST transformations for the Groovy language. And in general, it was with Gorm and Groovy, we started off with completely computing everything at runtime, being fully dynamic in terms of intercepting a method call called find by title and transforming that into the equivalent Hibernate query and then executing that on your database for equivalent JPA-QL query, essentially. It was HQL at the time, actually, because Gorm was built in the days where JPA didn't quite exist yet. So as the problem with this approach is that, like with anything, when you leave something to runtime, the cost of computation of those queries grows as your application grows. So large Hibernate-based applications tend to start up slow because it has to pre-compute all of this stuff and so forth. So leaving it to runtime, again, was a little bit wasteful. So with that in mind, we could have just done something similar to Gorm or Spring Data or whatever with Micronaut and done everything by reflection and runtime interception. And that would have been the easy way to do it, probably. But instead, what we did was we decided to really change once again how these things are implemented. So with Micronaut Data, what Micronaut Data does is it pre-computes your queries, your database queries, at compilation time using the source code model of your entity model. So if you think about Hibernate, for example, waits until runtime and then computes what's called the Hibernate entity meta model or JPA meta model. And then based on that meta model, it can build queries that then target the database. With Micronaut Data, and specifically Micronaut Data JDBC, we move that entire meta model into your compiler. So instead of waiting until runtime to compute that meta model, we compute the meta model inside your compiler, and we build the queries at compilation time and store them inside of your annotation metadata. So why, you may be wondering? The reason why is because what we can achieve is essentially a zero runtime overhead database access solution. So, frameworks and toolkits like Gorm for Grails and like Spring Data do have a fair bit of runtime overhead. And that runtime overhead exists because you essentially have to, map the objects using reflection and generate proxies at runtime and so forth. And after we introduced Micronaut Data, they, once again, the impact on the industry was large, and folks tried to adapt and so forth. But as yet, we have this architecture that we know is super fast and efficient. And even now today, if you compare Micronaut Data JDBC in benchmarks versus say Spring Data JDBC, you're looking at like 4 times X difference in performance. So that pre-computation allows us to really optimize the pipeline of executing your queries. And it also allows some other real benefits in terms of productivity. So one of the benefits is, if you define a method a query method like find by name or something, and that method, and you do it, you basically make a typo or you misspell the name of the method. Instead of failing at runtime with a horrible error and confusing error, we're able to fail that at compilation time. And because we're using Micronaut's completely reflection-free approach to AOP, we have much smaller stack traces, which makes it easier to debug applications because we don't have these enormous Spring / Hibernate / etc. stack traces. Now, speaking of Hibernate, we know that Hibernate is popular, and we know that JPA is popular. So we do have a version of Micronaut Data that pre-computes JPA queries, JPA QL queries, and uses Hibernate underneath. So this is for folks. Micronaut Data JPA is for folks who prefer the full-on object relational mapping experience that Hibernate provides, with all of the advantages and associated disadvantages of that model. So lots of folks really do like Hibernate, but it's definitely very feature-rich and it supports many dialects. But it does lean heavily on reflection and runtime proxies, and it is a very specific implementation, which some folks find just gets in the way. Other folks really love. So I think Hibernate in general, in my experience, is great for write-heavy applications. So if you're doing a lot of writes, the batching support and the being able to flush and manage transactions is excellent in Hibernate. When you start doing querying, it's a little bit less great because a little bit less than great because there's significantly more overhead than just using something like JDBC a simple data mapping solution, and some features like lazy loading and proxying, some folks just find get in the way, and so forth. So we do have support for JPA, and some folks love it, some folks don't. Just like some people love JPA and some people don't in general. Then the second implementation for Micronaut Data that we have is Micronaut Data JDBC, and that is essentially a native implementation for JDBC where we actually compute directly SQL queries. So it's a pure data mapper approach. It's not an object relational mapping toolkit. It's, I have these records coming back from the database, and I wanna map them to these POJOs. There's no ORM concepts. There's no lazy loading. There's no proxies. There's no none of that those things that you would typically associate a object relational mapping tool in it. And it's focused on essentially the use of data transfer objects and immutable objects. So whilst I find, typically with JPA, I see this approach that many people use of having a single entity, so one class mapping to one table. Micronaut Data JDBC is not about that. You may have multiple classes. You use the same table, and you may have database views or custom queries, or it's not necessarily the case that you have a single entity to a table approach. You might have multiple data transfer objects. It's all about fetching the right data at the right time, and it's much lighter weight, and it's completely reflection and proxy free. So this is, I think Micronaut Data JDBC is the really interesting part of Micronaut Data. But it's still a choice that you maybe need or want to make. So for example, here's the various pros and cons, I guess. So for of JDBC versus JPA. So in general, using Micronaut Data JDBC is way more efficient. So, in our benchmarks, again, you're looking like it's significantly faster using Micronaut Data JDBC for read-heavy applications than it is to use JPA, which has greater memory requirements, has the notion of a session and flushing, and has to translate JPA-QL to SQL or JPA criteria to SQL, and then back and forth again. It's just has more layers and more inefficiencies. Whilst JDBC is just like directly executing your JDBC queries and mapping those to objects. So it's just way more efficient. On the other hand, Hibernate does have a long history and has been around for a long time. So it does have support for some pretty ancient and niche dialects. So, if you need to write data to, I don't know, fire, some weird niche database that nobody uses, then yeah, sure, there's a lot more dialects out there for Hibernate. But whilst Micronaut Data JDBC, we have a SQL query generation for, just the major databases out there. Micronaut JDBC is also, focused around the use of data transfer objects for querying. You might have lots of different objects to retrieve just the right amount of data that you need, whilst Hibernate API tends to be focused on the single entity to table model. And although you can use DTOs, and you should use DTOs with Hibernate, it's generally not the way the thing is marketed and documented. But that's generally the way things are. And I would say that using JDBC directly and Micronaut Data JDBC is definitely optimized for reads. You'll get much more efficient reads if your application is read heavy. Then it's far better. Whilst Hibernate is pretty great if you need to synchronize a large object model in batch to the database. The whole session entity manager concept and batching up a lot of writes into one big bang using the session can produce very optimized write operations. So, and JDBC is, again, if it depends on your application architecture. Once again, are you doing serverless? So Micronaut Data JDBC is significantly faster to bootstrap, even with GraalVM native image, than Hibernate JPA, where cold starts are, Hibernate takes a while to bootstrap, even with all the improvements that have been made recently. So those are the kind of things you need to think about when comparing the two. And but anyway, in terms of what it looks like, what does Micronaut Data look like? So essentially, if you've used something like Spring Data or Apache Delta Spike or Gorm with its service concept, it's very similar in that you define a interface, you annotate it with @repository, and the interface can extend one of several different built-in interfaces like CRUD repository, and then you go and you define methods such as find by name or etc. And it's pretty simple in that sense, and those methods are implemented for you at compilation time. So that's the big difference between Micronaut Data and anything else. So in a typical CRUD example, you can inject the repository and you can instantiate an object, and you can call save, and then to read back, you can query, like, for example, find by name to find that person. You can do batch updates, so using, say, update person, passing in the ID and the properties you want to update, and you can delete by ID or by name or whatever. So that's what CRUD looks like. So how does Micronaut Data do it? So if you think about how queries are, you typically define a query. They're normally like, if you think like find by name. So there's normally a stem. So that's, in this case, it's find, and the stem can be find or search or get, or then we have pretty common verbs. And then there's an optional projection, which you're allowed to say, for example, find role by, or find name by something. So if you want to project on a particular property, that can be, and I'll demonstrate that in a minute. And then you say by, and then the name of the property, for example, find by name. And then you can optionally end the query with an order by statement. So you can say find by name, order by age, or something like that, to formulate the query. So that's how we analyze the method signatures, and we translate those into queries. Now, in terms of Micronaut Data JDBC, each repository interface in Micronaut Data JDBC, instead of being annotated with @repository, is annotated with @JDBC repository. So you can see, you can extend built-in interfaces, and you say @JDBC repository dialect equals, and then the dialect that you're using. So why do you put the dialect here? The reason that the dialect happens at this point is because the queries are computed at compilation time. So we need, they're not computed at runtime. So we need to know the dialect ahead of time. So a lot of folks will say, oh, but I want to use H2 in my tests, and I want to use MySQL in production. So I want to switch dialects, and that's completely the wrong approach. You should use MySQL in your tests, and you should use something like test containers. And that's the approach we encourage. So next. So the JDBC dialect is specified on the interface. So in this case, it's MySQL, but it ensures that the correct dialect is used when computing queries. And there's different dialects for Postgres or H2 or Oracle or MS SQL, etc. You have to specify that up front. And with that information, let's start doing some live demoing. And I'm going to switch over to this application that I was, using in my previous talk. So, in the previous talk, I had defined this controller class, which was, and I'm just going to switch back to returning a list. It was essentially using injecting a person repository, and the person repository was calling list people. And we're just going to do this for the moment. I will get to an explanation of how to use reactive types in a minute. And it was a nat singleton and etc. And life was good. So this is obviously using like just in-memory hard-coded values, which is like not what you would typically use in a production scenario. So how would I introduce Micronaut Data, in this case Micronaut Data JDBC, into the picture here? Well, the first thing you want to do is instead of introspective, what I'm going to instead do is I'm going to say this is a mapped entity on my person class. Notice how, unlike JPA or with Micronaut Data JDBC, it's completely acceptable for these things to be immutable objects, which is nice as well when you're using, for example, Kotlin, because you can use mapped entity with Kotlin data classes. The only maybe difference, maybe we want to kind of add an ID and have this as a generated value. Can that be the ID, like so, and then add a way to set the ID. There we go. So that there is my person class written in and mapped to a table called person. Now that can obviously be customized as well. You can say customize using the value of the mapped entity and specify that this maps to table person or whatever that may be. And also, some folks do prefer to, rather than using Micronaut Data annotations, they prefer to use JPA annotations. So we do support that. So if you want to add a dependency on the JPA API and instead use @table here, etc., to define your entities, we support that as well. So that's essentially a person entity. Now, in my repository, what I can do here is I can come in here and I can say this maps to JDBC repository, and we're going to use the dialect, and I'm using H2 as my dialect. And instead of a class, we're going to make this an interface, and we're just going to delete all of these for the moment. And we're going to extend from CRUD repository. And now CRUD repository is one of the different interfaces that you can implement. So, there's a few of them, which I'll show you here. So you've got CRUD repository, generic repository, page repository, and then in the async directory, you've got async CRUD repository, and you've got a reactive version, which allows moving the JDBC operations onto a IO thread pool and using reactive types and so forth. So with that, I'm going to extend CRUD repository, and CRUD repository takes two generic arguments. The first generic argument is the type of the entity, so in this case, person, and the second one is the ID types, in this case, long. So if you recall, when I defined my ID, it's of type long, so that's why I use long here as the second value. So with that in place, now back to my controller. Obviously, I have some compilation errors happening here now. So the first thing is obviously I need to implement these properly. So with CRUD repository, I could use find all. Oops, it's still a compilation error. Let's have a look. So actually, yes. So find all by default returns an iterable. So I could come in here and return a iterable here instead. But another option that you can instead do is any parent method can be overridden. So I can say override find all, and let's make it return list instead of iterable. There we go. So now it's returning and find all, which is going to return from my database all of the entities. Now, remember that Micronaut is based on Netty, the default Micronaut server. We do have servers for, we do have support for servlet deployment now, such as Tomcat and Jetty and so forth. So, which are, more the kind of request per thread model. But in this case, because I'm using essentially blocking JDBC, there's a few ways that we can essentially make sure that our operations that we're invoking on our JDBC queries are executed upon a IO thread pool. So one way would be to make this return a flowable, and that would be managed. Another way, which I'm going to start off using, is saying execute on task executors.io. And that will make every operation in my controller execute on the IO thread pool, so that I can use blocking operations safely without blocking the event loop. So, so with that, I have find all implemented. Now, what about find? So in my repository here, what I can say is I can say person find by name string name, like so, and just without implementing it. And then I can use that find by name in my method, and there we go. I have implemented that use case. So next thing, oops, I'm just going to come back in here and roll back these changes. So how would we populate data into the database so that these, query methods actually return some data? So, because if you recall, I have my test here, and when I run my test, which I'm going to do now, I actually anticipate that this test will probably fail, which it does. So it fails twice, in fact. It fails. The first test failed. Find person fails because the query produced no result, and I'm doing query. And the second query fails because the expected result size was 2, and in fact there's no records coming back. And that makes sense, right? Because I'm starting off with an empty database. So let's populate some data into my database. So I'm going to make my application class the bean itself. Then I'm going to make my define an event listener called init that's going to listen for the startup event. And then I'm going to also define a local variable for my repository and inject that into the constructor. So I've got a whole reference to my repository. Now in my repository, I'm going to say save all arrays as list, new person, red 35, new person, Bob 20. So, and that's it. So I'm using the save all method of the CRUD repository interface, which will check if every object is valid. Notice how on the interface, that's an important point actually. So notice how it has @valid. That's key as well. @valid is part, and @not-null, that's part of the essentially the validation support in Micronaut. And if you recall my person class, it has some validation constraints on here saying not blank and sizes that whatever. So if I violate these constraints, then my save operation would fail. So now if I run my tests, we should see the case that essentially they will pass, and they do. Yay! So my tests are passing because now I'm populating 2 records in the database, and I've essentially implemented support for persistence to a local database. So a few key things to point out here about why this is all working. So one thing is that I have in my data sources, Micronaut Data JDBC does have a feature which we do not recommend using in production, but I'm using it for this demo, which is essentially generating and creating the schema at runtime and dropping it. We recommend involving a fully fledged database migration tool like Flyway or Liquidbase. In fact, Flyway works great with Micronaut, and that's the one we recommend. But in this case, for this demo, I'm using that to set up the data. So you can see that, and if you don't believe me, that actual queries are being implemented. So I think I'm still getting my trace logging from my HTTP call, so I'm going to disable that. And in my logging config, I'm going to say logger name equals io.micronaut.data.query, and I'm going to say level equals trace. And I'm going to run my tests again. And you will see that when I execute my test, you can see the query that is being executed to find the person to select with all the escaping and so forth doing automatically. So we get all my query logs just by enabling this this logger, which is exactly what you want. Now, another important thing to point out, and this is part of the Micronaut experience, is that I have a test here, and there's a lot going on. There's a heck of a lot going on here. I've got an HTTP client being injected into my test. The HTTP client is making a request to my server. The server is making a request to my database. The response is coming back, and everything is happening, and I'm running it, and I'm able to do and the test is executing pretty much instantaneously, right? We have this, if you see the test execution speed there, but it's like 534 milliseconds. So even though we're involving a lot of relative complexity, I'm still able to write tests and execute them and do this kind of test-driven development. Gone are the days, I remember a few years ago, waiting for your Spring app or whatever to whatever it was to load, or people having to do things like separate out their integration tests from the unit tests because the application takes so long to start up that you have to have a separate test suite to deal with the fact that it starts so slowly. In Micronaut, you're able to build entire very complex applications, and the startup time just never really degrades, and you're still able to execute things and fully exercise your application. Micronaut doesn't have any kind of like mocking layer. Of course, we allow you to. We're not going to take away Mockito or anything like that if you want to use it. But in general, it's unnecessary with Micronaut. You can completely test your full application in your unit test, and everything just executes super fast, super speedy, and things work great. So that that's like a simple example. Now, I think a question I got in my last talk was, what about transactions? How do I deal with transactions? So the first point here is that the Sable method, when you call do Sable, if you don't declare any transaction here, then there is a implicit write transaction that Micronaut Data uses, and we have a transaction manager. In fact, if you want, I can inject it here. It's called Synchronous. Synchronous transaction manager, and the pipe that has this connection. So, and that will give you the actual transaction manager if you want to do programmatic transactions directly. So I can say assign this to a local variable. And then what you can do is you can say transaction manager execute write new transaction callback, like something along those lines. And we can stick this all within that transaction, like so. You can use lambdas, and if you don't want to use that. And the status object that gets passed in is the transaction status, and you can get hold of the underlying JDBC connection, and I can prepare additional statements or execute additional calls associated with this transaction, or I can call set rollback only and roll back the transaction, or I can throw an exception and roll back the transaction. That's how you do programmatic transactions. The other option is declarative transactions. So, I can get rid of this completely and move that out again. And in addition, I can add transactional, and the actual annotation is just the Jakarta javax.transactional API. And we do actually have another annotation that's Micronaut specific. So it's called transactional advice, like that. But in this case, we have, like many things in Micronaut, just essentially mapped the behavior of the JTA one onto Micronaut's transactions. So that will define a transaction on the init method. So if I had like multiple calls here to save multiple objects, and then something went wrong in the middle, it would essentially roll back the whole transaction, and things would be reset. So yeah, that's how you wrap an outer transaction. And of course, you can also it's quite common to this repository object here is an interface. And it's quite common to say, instead make this an abstract class, like so, and make these abstract methods that are implemented automatically for you. And then hold on. Override. Doesn't like that. Let's just pull that list for some reason. So it's I see it's supposed to implement. That's what the problem was. So you can make this an abstract class that then implements CRUD repository, and that'll essentially receive the same thing. And what you can then do is essentially use constructor injection here. So I could define a constructor, and I could inject objects, other repositories or whatever in here. And I could define an additional transactional method here called setup data or whatever, like so. And instead of having this kind of hard-coded in here, I can stick it in there like that. And then I can use my repository and say, setup data, and move this out into a more kind of refactored setup where my repository is responsible for reading and writing data and so forth. And that will essentially achieve pretty much the same thing as before. Except now all my data access logic is in the repository class and not spread out into my application class and everywhere else. So that's how you deal with transactions. And so in addition to these kinds of methods and so forth, you can also, as mentioned, if you don't want to annotate your controller with execute on and use kind of blocking operations, then instead of returning list, I can instead return a flowable here, and instead of returning inserting a person, I can return a maybe or that kind of thing. And then in my controller, I can return the flowable directly from here. And what will, and this would be a maybe, like so, in Narek Java. And what this does is essentially automatically places the operation into the IO thread pool so that you don't have to manage it yourself. And obviously that does that for one method. If you want to do it for multiple methods, then the way you would do that is in this like abstract repository. You could, for example, if I wanted to make a non-blocking version of this one, essentially I wanted to delegate the setup data method to the IO thread pool. What you could do is something like this, something like this, or it could be even completable, like so. Then completable, callable, and this would be setup data, subscribe on pillars of IO, something like that. Maybe this has to be new callable. Something along those lines, I imagine, will from callable from action from runnable is probably what I want. Something like that. And that will essentially achieve the same thing where you're wanting to place the blocking operation onto a isolated thread pool. Now, clearly there are also like reactive drivers that are up and coming and so forth. And we have it on the roadmap for the next version of Micronaut Data coming up to support the R2DBC, potentially other reactive drivers to make a fully non-blocking version of the SQL for SQL database access. But given the maturity of those is still developing, and the JDBC is far more mature and proven in the wild, that we prioritize the JDBC implementation for the first version of Micronaut Data. So that I expect will be out towards the end of this year when we have more support for that. So in terms of compile time checking, which is what I mentioned before, one of the things that I mentioned as well was that we were able to do a lot more compile time checking, and take for example this repository method here, find by name. Now, name is clearly find by name. Name is referring to the name property of the person class, as you can see, name. But if you made a typo, for example, find by num or something like that, and maybe I should just refactor that rather than use find by num or something like that. And I tried to run that and compile it and so forth. You'll see that you get a compilation error. And this is the kind of quality of life features that you get with Micronaut by moving stuff to the compiler, because we can do early checking that your application is correct. So you can see that it's like should be find by num, but it should be find by name, but it's find by num. So we get to do that kind of early checking of your code, which is really awesome. And another thing I wanted to show was if I just create another test here called person repository test, and make it a Micronaut test, is that the way Micronaut data essentially works is that it encodes on each method query into the annotation metadata, and then all it has to do is execute it. So like, let's say test find by name. And actually this gives me a chance to demonstrate another interesting feature of Micronaut. You know, a lot of frameworks, they need to get a reference to be able to execute a method. And the way you do that is, you know, by reflection, obviously. But we'd encourage not doing that in Micronaut. You really don't want to invoke things via java.lang.reflect for all the reasons that I explained before. And there is a way to do that in Micronaut. And what you can do is on any method that you want, you can say at executable. So I'm going to add at executable on this method. And then I'm going to, actually, I want to get hold of the private final. I'm going to get hold of the bean context, the right bean context, the Micronaut bean context. Get hold of the bean context in Micronaut is like you know, for those familiar with Spring or CDI, is basically a context object where you can get hold of information about the various beans that exist at runtime. So you can say get bean definition, and I'm going to get hold of the person repository.class. So, and then I'm going to say get required method, and then the name of the method is find by name, like so. And it takes a string, so string.class. So this is you know, this is your equivalent of get declared method on java.lang.class, reflect.class, to get hold of a method, and that will get hold of what's called an executable method. And the reason why I want to demonstrate this is because the method also contains the annotation metadata. And you'll see that if I run this, hopefully you'll see anyway that oops, the parameter rules all doesn't like me injecting the. Let's do this approach first. So you can see I ran that, and you can see that when I run it, the SQL query is actually stored in the value of the query annotation. So what Micronaut Data actually does is at compilation time, it computes the query statically. Yeah. So there it is, and stores it in the annotation metadata. So imagine this is the at query annotation. So that SQL is essentially stored inside the annotation metadata. So all Micronaut Data has to do is essentially retrieve the query and execute it. It's really simple and really efficient. You wouldn't be able to write a query faster yourself. So you know, and it's using this at query annotation. So that has implications for you as well. For example, you know, if I wanted to make this a custom query, i.e. I didn't want Micronaut to implement this method, you can add at query explicitly yourself. So you can say select star from person where name equals name, like so. And that's essentially the way that you would, you know, define your own custom query. So in this case, I'm defining the query directly. So you know, you could use, you know, stored procedures and whatever other custom query logic you want in here, and you know, parameters can be referenced using colon and then the parameter name for name parameters. In this case, that's referencing that. And I believe we even do type checking to ensure that the name is the name matches the parameters. So you can define custom queries with at query. And if you don't, if you don't, if you omit this, then Micronaut Data will try and compute the query for you, and if it can't, it will fail with the compilation error. So that was a lot of demo already, and to make sure that I have enough time for questions. Like I said before, Micronaut Data and schema migration, you should always pair Micronaut Data with a schema migration tool, whether that be Flyway or Liquibase. And in Micronaut 2, we have support for Flyway with GraalVM native image, which is really cool, because you can use Micronaut Data JDBC with any of the database with the native image, and also implement your database migrations with Flyway. And in general, database schema generation with Data JDBC is just for quick demos and experiments. You should always define your schema yourself and manage the state of it and so forth. So we recommend that. In addition, I didn't demo that, but essentially you can use DTOs. So you can define any kind of DTO. For example, I can say I can have a person age, or just call a person DTO for the moment. So this is going to be another object, and in here I just want to get the person's age, and maybe a whole bunch of other properties, and create a constructor, depending if they haven't had more properties. And then I can use this DTO in a return type. So instead of returning a person, I can say return the DTO, and what will happen is Micronaut Data will build a query that only selects the age property, or if I had other properties in here, only selects the properties you're interested in. This makes it very easy to just retrieve the data that you need, because the problem with solutions like Hibernate is that everybody ends up building really, really inefficient applications, because they're always retrieving the whole object back from the database with all the table rows and all of the data, and it's just not very efficient. So with DTOs, you can reach in and get just the information that you need, which is super cool. And they can be immutable and so forth. And they work really well with Kotlin data classes. As demonstrated, you've got Micronaut Data transactions. You can use either Micronaut transactions, or we do have support for the Spring Transaction Manager. So if you prefer to use Spring managed transactions, we have support for that. But the Micronaut based ones are more efficient and have filtered out a lot of the legacy that Spring has to maintain for old Java EE containers and all the junk that is not really needed anymore. And oops, I think I have 1 second. Whoopsie. Somehow my slide jumped. Apologies for that. Another important point is that Micronaut Data is about static versus dynamic queries. So Micronaut Data's strength is really in static queries, not in dynamic queries. So for dynamic queries, or where you need to dynamically build a query based on user input data. For dynamic queries, for JPA, you should use JPA criteria. With Micronaut Data JDBC, we recommend pairing Micronaut Data JDBC with something like Duke, which works really great, or JDBI for doing query building and dynamic queries. Or for GraalVM, for native image, we support native image with both the JPA and the JDBC implementations automatically out of the box. We have support for all of the popular databases from Postgres, MySQL, Oracle, MS SQL, and H2. There are massive improvements in this area in Micronaut 2. It just works out of the box. And which I'll probably demonstrate in a minute. In fact, I may as well do that. So whilst we're waiting here, so in my application here, what you can do to build a native image is essentially do Gradle symbol oops, I have broken something in my app. Let's see, 1 second. So probably it's that person PTO business. There you go. Okay, so let's try that again. Okay, so what you do is you build the app into create the kind of Uber job for it. And then what you do is I have, if you look at the Java version I'm using here, I'm using the latest version of GraalVM Community Edition with native image still installed. And what you can say is native image, I typically don't run the build on the server and say no fallback. And then you do build.libs and point it to your fat job and you execute it. And that'll go and build, not found. So that normally would go and build my native image. Let's have a look at my entry point. See, JPoint application. Gradle W clean assemble. For some reason, I have got a build configuration error here. Let's see, JPoint application. Yeah, well, anyway, I'll work that out later. So basically, you basically build you point it to the Uber jar and build it, and it does build. I've obviously messed up something in my project template, but this is the joy of live demos. So, so Micronaut Data roadmap 1.1 is the current version. For Micronaut 2, we have, like I said, upcoming support for R2DVC and reactive database support. We'll be looking at document database support, graph database support, and a lot more. We will, like I said, Micronaut Data fits naturally in with Micronaut applications. It provides this zero overhead database access solution that reduces memory consumption and improves performance. And GraalVM native image support is out of the box, although, in my application, I seem to have messed something up, but don't worry about that. And with that, I have got time for some Q&A, I believe. Questions?
Yes, we do have some questions in the chat. That was an interesting presentation. Thank you, Graeme. The technology really looks nice and pleasant to use.
Yeah.
The feature that you showed about checking the name of the method when you made a typo, like find by name, and omitted the last e. How do you actually verify that it should be by name and not by num? Is it the parameter name that you rely on, or is it something else?
No, it's the method signature. So if you look at the repository here, it's saying like find by name, and name is obviously matched onto the name of the entity, and and if it doesn't match, essentially we also compare the types. So if I tried to do an int here, you would also get a compilation error. So the types need to match. So we compare that this has to be a string or it has to be a compatible type, and then it matches. And there's a lot more that you can do with the syntax. So you can say find by name like, or you can do things like find by age greater than, and put in the age. You can say, find by age between, and have min age and max age. There's a whole expression syntax, and for those who are familiar with Gorm, the actual implementation is actually based on a fork of Gorm. So if you're familiar with how Gorm works, then you'll be up and ready and really familiar with how Micronaut works.
Okay, nice. And you mentioned type checking. You mean type checking against the data definition, like in the source code, or type checking inside the database as well?
No, not in the database. In the source code, we don't connect your compiler to the database. Not yet, anyway. That maybe is the next step.
Yeah, that would sound like a very interesting feature, that you connect to the database and then you fully verify at the compilation time.
Yes. So actually, there is there's a lot more that can be done at compilation time, and we're definitely going to be looking at those kind of areas, particularly for generating your data model and then verifying it, like you said.
Perfect. So we have more questions in the chat. Is there something similar to Spring's JDBC template in Spring Data?
Yes.
Not the Spring Data, sorry, in Micronaut Data.
Yes. So in my personal repository here, what I can do is inject JDBC operations equals JDBC operations, and create inject that as a field. Then in here I can say JDBC operations dot execute, and you can pass in a connection, the callback, which essentially allows you to work with the connection, the current connection. Another thing you can do is say prepare statement. And I can say select star from person where something like person where start from person p where person.name equals question mark, something like that. And then I can put a prepared statement callback in here, and do statement.set string, like that, and then the name, whatever name I want to query, like so. And then once you've got the statement, you can say return JDBC operations .read DTO statement .execute query, and essentially read the DTO from that read entity, the method. Read entity type person and collect, and that will essentially return a individual entity. So if I was reading an individual entity, or you can also say read entity stream, essentially. You can say entity stream, like so, and collect vectors to list to get a list of all entities, and that sort of thing. So that's essentially how you would implement this in a kind of JDBC template style. So you pass in the select, you receive the statement, you set the values, and you call entity stream on the statement and collect the data. So that's pretty much a template
looks
style
really
approach.
familiar.
Yeah.
Okay, then we have another question related to performance. So are there any benchmarks that show Micronaut speeds for complex queries, like selects with joins, something like that?
So again, it's more about what are you benchmarking. So, are you benchmarking how optimized your query is, or are you benchmarking the overhead of the framework you're using? So like if you're talking about, there's not going to be any difference with the same in terms of executing the speed of the query versus Spring Data JDBC versus Micronaut Data JDBC. Where there's going to be differences, and that's regardless of the complexity of your query, is reading that data back and turning it into objects. And that is because there's very little overhead in Micronaut in terms of executing the query and mapping it back into objects, essentially.
Yeah. So there is another question which is kind of related, I think. So is there any comparative load tests with Spring Data for inserts and updates? So basically, Spring Data is dynamic, as I understand, right?
So in terms of updates on Micronaut Data JDBC, so the way you define updates is essentially you can define like a method. Like, for example, I can say return the number of update person ID and the ID of the person, and then I can just put the properties on an update, so it's string age and so forth, and that will essentially do a batch update by ID. You can also do things like update person by name, and then put the name of the person. Name of person int age, and that will do a query by name and just do a batch update of all the ages of the matching people that match that name. So those are kind of like just using JDBC batch queries, right? They're not. There's really nothing dynamic about that in terms of producing. And this is what I said. It's all about Micronaut Data is all about static queries. It's not about building a dynamic query. If you need to build dynamic queries, and I'm not sure that Micronaut Data, Spring Data JDBC has anything for that either. It's more about using something like JDBI or Juke or something like that. Micronaut Data is really about static queries.
Okay, then there is a simple question. I believe the person is asking if Micronaut will use the prepared statement for a simple query like find person by name, or is it still like a concatenated string probably, or a statement?
It's a prepared statement. So when I did that demo of where it is the query that gets output, that's essentially the prepared statement that is built into a string. And if you look at the actual implementation, of Micronaut Data JDBC, we're using prepared statements. So that all Micronaut Data is actually doing is retrieving the query and executing it, and then mapping those results to actual objects. And the way that it's done is really efficient because it's using the introspection stuff in Micronaut, which means there's no reflection, there's no runtime proxies, and so forth.
Okay. Another question. So we have a lot of questions. Is there support for calling transactional method of some bean from the other bean? I'm not sure I fully understand this question, but maybe you do.
Yeah, so that I'm actually doing that right here. My application class is a bean. My application class is one bean. So this is one bean, and it's recording the repository class, which is another bean, which is annotated with that transactional. So the actual transaction will only be activated when I call this method. So that's, I think, doing what you mentioned. What is being described? Yeah.
Okay. More questions. Are there any benefits of using Micronaut Data JPA over Spring Data JPA, and in what cases it's better to use Micronaut Data JPA than Spring Data JPA?
So there are benefits in that with Micronaut Data JPA, we are pre-computing the JPA QL queries, and we're not using any runtime proxies, any reflection, anything like that. So it's far more memory efficient overall. It performs better, but the performance difference is not as big. It's only around like, I think 2-3% or something like that, which is not like huge, but but in terms of operations per second, but the memory saving will be big because we're not using reflection, and the startup time will be better because obviously there's no overhead of loading Spring. It's just instantiating objects, and it's much faster.
Okay. Oh, there is an addition to that bean calling other bean method. So with Spring, when you're calling the transactional method from within the same bean, there might be an issue. And is it the same with Micronaut?
No. So we do everything at compilation time. So if I was to define another method here called void blah and whatever, and I would do setup data, you would still get a transaction. They wouldn't. I know the problem you're talking about in Spring. If you do this in Spring, you bypass the proxy handling in Spring because it's done at runtime, and then this becomes not transactional. So the answer is no. In Micronaut, that works as you would expect because we do everything at compilation time.
Perfect. So one more question. What is the correct way to run complex queries, like with left joins, grouping, window functions, etc.? Should I write them manually inside the query annotation or somehow differently?
There's different ways. So if you have a really large query, obviously, inside the query annotation, if I do have a query here and it's really a big query. Now this is slightly better in JDK. Can't remember the version, but one newer JDK where you've got like multi-line strings where you can stick a whole bunch of data in here. But it can still be ugly. So one way you can do that is to use annotation metadata. So I can say, I don't know, person.find query, whatever, and then essentially stick this in configuration, person find query, something like this, and then have select star from whatever and have it configurable either in properties files or whatever, and then it's not clouding all of your actual code. So that's actually a one way to do that. If you don't want to have super long multi-long lines of queries in your repository classes.
Okay. So it seems we are out of questions in the chat, but I will add my own stupid question. Micronaut Data looks like a very nice, data library to be used in your favorite project, but is it possible to use it without Micronaut, like separately?
It is. I just figured out what I did wrong with my native image build, by the way. I admitted I did that. This has to be on the class path. Sorry, interrupt. It's a problem doing live demos. So I omitted the -class path bit, and now it's building my native image. Sorry, what was the question again?
The question was, is it possible to use Micronaut Data without Micronaut itself?
Yes, that's right. Yes, it is. So so you can, we have users who use it inside Spring. And one way to do that is just to essentially, because Micronaut is really lightweight, essentially bootstrap Micronaut within Spring. And I don't have Spring code on my class path here, but it essentially looks something like data configuration.
Well, I just wanted to know if it's possible or not. Actually, we have just 20 seconds left in the live session, and we should move into.
I don't know if 20 seconds is enough to build this native image. You know how long native image takes to run, but it is
10 minutes.
It is building my native image, and yeah, basically, this application is fully native imageable. as long as you run native image correctly and are not silly like me and miss the class path argument when writing your CLI command. So but yes, we should wrap up, and thanks for everybody for. Oh, look, the image didn't take that long. See,
It's there.
there you go. Oh no, it didn't. It didn't.
Demo
All right.
effect.
It didn't.
I had broken my application in the meantime. But anyway, if my application wasn't broken and I hadn't messed it up, I think I basically messed up my application somehow in the process. You would be able to run the application as a native image.
All right.
Okay.
All right, thank you, folks. It was really nice Q&A sessions. I'm really glad we have much questions there. Thanks everyone who actually posted questions, and thank you, Graeme, for actually 2 talks. It was a hard time, I guess, to deliver all the talks like one by one today.
Yeah,
but
I'm like sweating now. Seriously, it's been
I see.
but it's been a lot of fun, and I hope I get an invite or my proposals accepted next year. We'll see.
Oh, yeah, we'll see you. Probably, yeah. Probably we'll have offline conferences next year, so I guess we'll meet you in person. And thank you, folks, Anton and Yuri, for the Q&A sessions and helping there. Yeah, hopefully to see you soon as well. And by the way, we will have a discussion zone in the Zoom webinar, so please go there. It's kind of this way below your player, so feel free to get there and ask more questions. Okay, thank you, and see you soon there.
Bye.
Thank you.